All right, let's take a look at the circuit here. And we're given some conditions. We're saying under steady state DC conditions, we want to find the current I and the voltage V. So we want to figure out what this current is across here and what is the voltage drop over here. Okay, so a couple things to note is the keyword of steady state DC conditions. And again, we want to look back at the properties of capacitors and inductors, because we have both an inductor here and we have a capacitor here, and so they both behave differently in opposite fashion. So at DC, the capacitor, so at DC the capacitor here is going to be an open circuit. Okay, and then the inductor is going to be a short circuit. So now we can redraw the circuit to display that. So let me go ahead and try to redraw this here. We have our current source going up here. We have our resistor. The inductor is going to be a short circuit, and then we have our other resistor here, connect it here, and of course our capacitor is going to be an open circuit there. Voltage drop across these parallel elements is going to be V. Our current is going to be here I, and this is 5 milliamps. Okay, so this is our equivalent circuit where we have 30 kilo ohms here, 20 kilo ohms here. So we've just simplified the circuit, and now there are a couple ways we can approach this problem. One way we can approach this problem is use current division to figure out what the current is going through. To figure out what this current is, we can use current division, or we can do KCL. So I'll do both ways just so we can see the approach. You're going to get the same results, of course. So let's go ahead and do this. I'm going to say method 1. Okay, method 1 should be a D. We want to use current division, and we don't always remember or memorize these equations, so sometimes it's better to go to the traditional one, which was going to be method 2. Alright, so if we're going to do current division, so that states that I, go and zoom out here, I is going to equal to 30 kilo ohms over 30 kilo ohms plus 20 kilo ohms, all times the current coming in here, which is our 5 milliamps. So our 5 milliamps here. If we calculate that, we get 3 milliamps, and that's the solution to the first part of the problem. So I is going to be 3 milliamps. Okay, then from there we can just use Ohm's law, say V equals IR. Okay, so we know that I is 3 milliamps, and our resistance going through, and now we're going through, this I is going through the 20 kilo ohm resistance, so 20 kilo ohms, and that's going to give us 60 volts. Okay, so we've solved for this problem using current division. Let's just say you forgot the equation for the current division or that relationship. The other way you could approach it is just use KCL or Kirchhoff's current law. And so let's just write this down here. So I'm going to say method 2 is we're going to do KCL, and we can say, let's just say this is our node V, okay? And then what KCL states, remember, the sum of the currents going in has to equal to the sum of the currents going out. Okay, in this case we have current going in here, current going out there, and current coming potentially, excuse me, out this way. Alright, so let's just write that down. So the current going in is this 5 milliamps. So I'm going to go ahead and write this on the side here. 5 milliamps is equal to I, this yellow one, but we can write that as V minus, and then the key here is we gotta treat this as our ground here. Okay, we can call this our ground, or V naught, which is 0. So we say V minus 0 over the resistance there, 30, that's going out, plus V minus 0 over the second resistance, which is 20 kilo ohms. Okay, so this is 30 kilo ohms, and this is 20 kilo ohms. Right? And we can, now it's just a matter of solving for V. Okay, we can rearrange this equation, and we can, if you want a common denominator, we can multiply everything by 60. I can multiply this whole thing by 60, and that's going to give us, let's scroll up a little bit, that will give us 300 is equal to, zoom in a little bit, V over 30, V over 30 plus V over 20, excuse me, go back, we multiplied, so we get a, it's going to be 2V plus 3V, okay, and then we just simply solve for that. We get 300 equals 5V, and then V equals 60 volts. Okay, it's a little longer way of getting the same solution, but now we've solved for V. Again, that's in case you forgot the current division equation. Okay, now to get the current, we just go back and we just use Ohm's law again. V equals IR. So now we go I equals V over R, where V is 60 volts. R in this case again is going to be 20 kilo ohms, and then so I is going to equal to 3 milliamps. Alright, so these two different ways of solving for both the current and the voltage for this circuit here, one using KCL at node V as I defined it here, the other was using current division.